Hello, we're back again. Now, as you may have noticed, as I'm putting these videos out, I'm working through the double pages in the textbook to make sure that everything's being covered. We've done Lesson A, we've done Lesson B. Today's Lesson C is more of a way of bringing together everything we've learned in Lesson A and Lesson B. So let's just recap what we learned before we have a look at the objectives for this lesson. So in Lesson A, we looked at atoms, and we said that atoms were singular units on their own, the smallest possible unit or building block of any material. We said that if we put these atoms together, we can make molecules. And we said that if these molecules were made of different types of atom, like water, it's got hydrogen and oxygen in there, we said we'd call that a compound. This isn't a compound, it's only made of one type of atom. This would be an element. And then we went on to talk about here we go. Different types of compounds and element we might see. We talked about gold being an element and sulfur being an element, but here we can see the different types of atom in lead, sulfide and water, and they are compounds. That was essentially what we learned in Lesson 1, but do go back and have a look. We also talked about mixtures as well, so if you can't remember that, do check out the Lesson 1 video. Lesson 2, we started to talk about symbols. And here were John Dalton symbols, for example. We talked about symbols being part of an international language. So we use them, so if we speak different languages, we can still communicate about the same element with somebody in a different country without getting ourselves confused. We looked at Dalton using these symbols here and how confusing those symbols were. So we got to grips with the symbols that were on the periodic table. And we noticed that some of them didn't always start with the letter that we'd expect. We then talked about the fact that these elements are found in the Earth's crust as minerals or compounds that we can extract, usually oxide because they'd reacted with oxygen, and they were found in rocks called ores. Again, that was all in Lesson 2. So what's Lesson 3 about? What are the learning objectives? Well, I think a lot of these we'll be able to have a good go at answering already, but let's have a quick scan. We can describe and identify metals and non-metals by their properties. Now, we talked about what properties meant in the last lesson. We talked about things like boiling point and melting point, etc. So we're going to look at what properties are particular to metals. And we also talked about the second objective. Can we relate the use of an element to its properties? How do we know that an element is particularly suited to be used for a particular task? How do I know iron is a great element for building bridges with, for example? So let's start with this first one. I can describe and identify metals and non-metals by their properties. Well, if we look at the textbook, if you want to pause the video now, you can make some notes here, but we tend to say that metals are all of these things. They are solids with a very high melting point. Yeah, we've got to get metals very, very hot to melt them, which is why they're ideal for using as saucepans and frying pans. We know that they're shiny when they've been polished. Now, if they're not shiny, if they've been left out in the open a long time, then they may have reacted with a bit of the oxygen in the atmosphere to form an oxide, yeah, maybe an aluminium oxide or an iron oxide, and that might tarnish the outside of the metal, but we can polish that up, we can get it nice and shiny. We talked about them being strong and flexible. We said they were definitely good conductors of heat, definitely good conductors of electricity, and this word here, malleable, just take a second to see if you can remember what malleable meant. Malleable in terms of a metal means we can shape it. So we can take metal and we can bend it into a car. We can, you know, shape it into the shape of a filing cabinet. We can do something useful with it. And there was also one other word that isn't on this list beginning with the letter D, and that was ductile. And we said some metals, copper being a great example, are ductile. They can be spun into long wires. So they are the properties of metal. But how might you see that in some sort of an exam question? Well, you might get something like this. We've got two elements here, element X and element Y, and we have no idea what the names of those elements are. But question A below it says, explain how we would know whether these elements are metals or non-metals. Well, we now know the typical properties of metals. Do they have high melting points? Well, element X has pretty high melting points. Does element Y? It's not that high, but they both have very high boiling points. But the key thing for us is, are they good conductors of electricity? And if we look at and heat as well, and if we look at the bottom, both X and Y are excellent conductors of electricity. So therefore, we would say that, yeah, they are metals. Now, when we're looking at elements that conduct, or substances that conduct electricity, the only one that you will ever come across, at least for the next few years, that can conduct electricity and not be a metal when it's solid is graphite. That's just the one example, the one exception. So if we ever see a question like this and we're told that something can conduct electricity, we are going to assume it is a metal, unless we're given some sort of other information to tell us it might be graphite. But that will come in the future. Question B, relating now the properties to the use of the element. Which would make better cooking pots? Give 2 reasons for our choices. So which one would be better to use for cooking? Well, if we look at element X and Y for the melting point, we can see that Y melts at 98 degrees C. So if we use that as a cooking pot, we couldn't even boil water in it before the cooking pot itself started to melt. All right, so element Y wouldn't be a great choice for a cooking pot. If we look at the reactivity as well, it says it reacts with water. You may have seen in lessons your teacher taking some sodium or potassium or lithium and putting it in water and it reacting and sometimes even exploding or setting on fire. Right? Some metals do that, the group 1 metals. Right? We wouldn't use a metal like that for a cooking pot. So element Y would definitely not make, for those 2 reasons, definitely not make a good cooking pot. So let's just go back to the learning objectives for this. Describe and identify metals and non-metals by their properties. Well, like we said, as long as we understand if something has these properties, it's a metal, fine. How might that be assessed in the textbook page? Well, let's have a look here. What would we be expected to answer? So question 1, what is similar about the appearance of most metals? Most metals. Right, think about the properties we looked at. Hopefully you did pause the video and you wrote them down. And if you did, you might be thinking, well, most metals are shiny. Yeah, they might tarnish a little bit, but we can polish them, get them nice and shiny. Question 2, give the names and symbols for 3 metals and 3 non-metals. Well, I'm not going to give you the names and symbols for that, but I'm going to tell you how to find those symbols. If you get your copy of the periodic table in your journal or download one from the internet, what you will see somewhere on the right hand side is what looks like a zigzag line. Okay, a little zigzag or set of steps, a bold line on that periodic table. Everything on the left hand side of that line is a metal. Everything on the right hand side of that line is a non-metal. So if you're stuck in an assessment and you're asked to give an example of a non-metal, use your periodic table and choose something from as far right as you possibly can, and that's going to be a non-metal. Choose something as far left as you can, and that will definitely be a metal. But remember that zigzag line, that bold line, sometimes we have different colours that show it. That is a dividing line between the metals and the non-metals. So those 2 questions shouldn't pose too much of a problem. Let's have a look at these. Again, write down 3 properties of most metals. By now you'll be sick of hearing about the properties of metals and you'll instantly be thinking they are good conductors of heat, they are good conductors of electricity, they have high melting points, almost always, and they are shiny. Okay, and they are usually very, very strong. Question 4, what properties make the following suitable for their uses? Now remember, we have to be able to say why a particular metal is useful for a particular job. And this is exactly the type of question that would do that. Aluminium being used for lightning rods. You know what a lightning rod is? Something you stick in the ground, lightning hits it, so it can travel to the ground, and it protects the building that it's attached to. Yeah, the lightning, the current travels down the rod rather than through the building where we might be sat. So what kind of properties would we want in a lightning rod? I'd want it to be a good conductor of electricity. First of all, definitely a very good conductor of electricity. And I'd want it to be relatively light as well. If it's something that, you know, I'm going to want to stand up as a thin rod, I'm going to bolt it to my house, you know, how am I going to get it up there? I want it to be a fairly light metal. But the main one for that one is absolutely that it's a good conductor of electricity. Let's have a look at B. Using iron for radiators in the house. Why would iron be a good metal for radiators? Well, what does a radiator need to do? A radiator needs to allow heat from the water inside to get to outside the radiator, yeah, so it can heat our room. So iron must be a good conductor of heat. And it is. It's an excellent conductor of heat. But it must also be strong. Radiators live bolted to your walls for a very long time. They get lots of knocks and bumps, especially if you've got kids. They get banged into all the time. They've got to be strong. So iron would also be an excellent choice for that reason. It's a strong metal. Now, let's have a look. What have I missed? I've missed this term malleable as well. Yeah, iron is malleable. We can mould it into the shapes we want for a radiator. Let's not forget that word. Can you remember what that word was beginning with a D that means spinning into wires? Okay, hopefully you've just said ductile. So let's go back to the learning objectives, and I think you'll see that we've already got both of these covered. Describe and identify metals and non-metals by their properties. Well, we know the ones for metals. Non-metals are usually the opposite. Lower boiling point, lower melting point. They can't conduct heat very well. They can't conduct electricity very well. They're not malleable and they're not strong. They tend to just be the opposite. And this one we've talked about last lesson and here in the question with the aluminium and the iron for the radiator. Can we relate the use of an element to its properties? Okay, we've given examples of that and I'm sure you'll be tested on that more in the worksheets that get sent home. Right, now it is worth pointing out that there are some exceptions to the rules we've been talking about. If we take mercury, for example, mercury is a metal, but it has a low melting point. In fact, its melting point is so low that by the time we get to room temperature, it's already melted. It's a liquid at room temperature. But even as a liquid, it will still conduct electricity. Now, you might find mercury on some periodic tables in a different colour to the elements around it to show that it's got these unexpected properties. Other materials that have unexpected properties, I did mention before graphite and graphene. Now they are both made of carbon, and these are probably the only non-metal materials that you'll come across on a regular basis that conduct electricity. Now carbon can also be used to make diamond. Carbon is very, very varied, but you will, as you go through the years, learn much more about all the different forms of carbon: graphite, graphene, coal, charcoal, coke, diamond, etc. But just for now, be aware that graphite is a good conductor of electricity. Now, I did say that graphite and graphene are the only non-metal conductors that you'll hear about a lot, but it is worth pointing out that silicon, which is also a non-metal, right, but very shiny, which is usually a property of a metal, that can also conduct electricity. And we tend to use that in electronic chips, etc., as it says here. And as the temperature changes, so does its ability to conduct electricity. It changes quite rapidly. So, they are the exceptions. If we have a look back at the learning objectives for this lesson, I think we can all now comfortably describe the properties of metals and non-metals, which are just the opposite properties of metals. And I think we all understand now, when we're asked to relate the use of an element to its properties, I think we all understand what that means. Yeah, think about why do we use iron for a radiator? It's strong, it's a good conductor. You know, we've talked about that a few times now. So have a look at the worksheets you've been given. Hopefully you're getting the grip of this by now, and I will see you next time.